So we want to be able to calculate potential energies. And the first one that we want to look at is the gravitational. And gravitational potential energy is due to a change in your object's location above the surface of the Earth. So you can imagine you have some object and then you raise the height of the object. So the idea is if you call this, we'll use the letter U for potential energy and we'll use UG for gravity. So UG represents our gravitational energy. And so there's some energy here because your object is above the ground. And then as you change the height of the object, so you can think of this as like y1 and then y2. As you change the distance between the Earth and the object, you change its energy. So let's take a look. So we can think of this as like UG initial and UG final. So the idea is that UG initial, or UG final minus UG initial, this has to be equal to the work we did, because we said that work changes the energy in our system. Now what is the work we do? We said that work is the force times the distance it acts over. Well, in this case, the distance it acts over is y2 minus y1. And the force that acts, in this case, is the force of gravity, mg. So what we see is that UG final minus UG initial is equal to mg times the change in height. So normally what we would say is that because this is a difference, this is delta UG, would be mg delta y. So what we see is that the change in the gravitational energy is a result of changing your system's height above the Earth. So if you raise the book to a new height, it has more energy, gravitational energy. If you bring it back down, you reduce the gravitational energy. So we see that this is the change, but if you wanted to just calculate it for, let's say, either the initial or final, UG is generally given as mg times y. The mass, gravity, times the distance you are above the ground. So UG is mgy, and the change in the height gives you the change in the potential energy.